Hello everyone. In this video, I would like to answer these three questions. Okay. I would like to show you how to do them. The first question, we're looking for the second derivative of the function f(x) equals cosecant x. So to find out the second derivative, we will need to know what's the first derivative, and we said the derivative of cosecant x, that is negative cotangent x times cosecant x. Okay, and then to find the second derivative, we're gonna take the derivative of this result. Now, as you can see, this is a product of two functions. One, we can say is negative cotangent x, and then the second one is cosecant x. So ux I need to be negative cotangent x, and vx I need to be cosecant x. And we know when we use the product rule, we need to know the derivative of both. So I found the derivative of ux. The derivative of cotangent x is negative cosecant square x. Therefore, the derivative of negative cotangent x is gonna be negative of negative cosecant square x. So that's a positive cosecant square x. And the derivative of cosecant x is negative cotangent x times cosecant x. Okay, so once we have this, we can write the derivative of the second derivative of the function. So that's a derivative of u times v plus the derivative of v times u. So we plug in this back to the formula. We have cosecant square x times v, which is cosecant x, okay, plus the derivative of v, so it's negative cotangent x times cosecant x, and times u, which is a negative cotangent x. So you get cosecant x to the third, and negative times negative, the positives plus cotangent square, and times cosecant x. Okay. So that's why the answer is like this. Okay. Okay, for this question, we're looking for the equation of the tangent line to the graph at the given point. Okay, we're looking for the equation of the tangent line at this point. So to find that, we just need to know what is a slope at this point. What is the slope of the tangent line at this point? To find the slope of the tangent line, we take the derivative of this function. And as you can see, since this function is a quotient, so we're gonna use quotient rule. So the derivative gonna be the derivative of the numerator multiplied by the denominator minus the derivative of the denominator multiplied by the numerator and over the square of the denominator. So we're gonna have 36 times x squared plus 36 minus the derivative of x squared is 2x, and plus the derivative of 36 is 0, so just 2x times 36x over x squared plus 36 squared. And if we simplify this, we're gonna have 36x squared plus 36 squared minus 2 times 72x squared over this. So that's gonna be negative 36x squared plus 36 squared. Okay. Now, once we found the derivative function, the slope gonna be equal to the derivative function when x is equal to -3. So we evaluate this at -3. So it's gonna be -36 times -3 square plus 36 square over -3 square, which is +9, plus 36 square. Okay, and if you do that, put that in your calculator. -36 times 9 and plus 36 times 36, that's 972. Now over 9 plus 36, that's 45. So 45 times 45, so 2025. So that's gonna be the slope. And let me see. So y minus, now this is gonna be the point, y minus -12 over 5 equals 972 over 2025 times x minus -3. Okay, now if we simplify our answer, we're gonna have y plus 12 over 5 equals 972 over 2025 times x plus 972 over 2025 times 3. So y equals 972 over 2025 x plus 972 times 3. That's a 2916. Okay. All right, and then you can simplify your answer. So 2025 divided by 25. So 81, 2016 divided by 81, it's 36. Okay. And 972 divided by 25. Okay, cannot be divided by 25. So I have 972 over 2005 plus what that is, 2016 divided by 25. Okay. Okay, 2,916 divided by 81. Okay, that's 36. Okay, 36 minus 12 over 5. And we combine these two terms. So we multiply this by 5. So 25. We multiply 12 by 5. We're gonna have 60. So y equals 972 over 2025 x minus 24 over 25. Okay, now you can leave your answer in this way, and also if you simplify, I think you get so 2025 divided by 25. Yeah, because 972 we can write as 12 times 81, and 2025 we can write as 25 times 81. So if we cancel this, that will be 12 over 25x minus 24 over 25. Okay. All right, for the number 3, a ball is thrown straight down from the top of 455-foot building with an initial velocity of negative 24 feet per second. Use the position function below for free-falling objects. So here we assume there's no air resistance, so that's why it's called free-falling objects. What is the velocity after 3 seconds? So to find out the velocity, we first take the derivative of the position function. So we're going to have a v of t equals negative 32t plus v0. So here v0 is the initial velocity, and s of 0 is the initial height. So because it's a constant, when we take the derivative, it's 0. Okay, so the velocity function is negative 32t minus 24. Therefore, the velocity after 3 seconds, we substitute 3 for t, we're gonna have a negative 32 times 3 minus 24. So we have negative 93 minus 24. So that's negative 120 feet per second. Okay. Now for the part 2, what is the velocity after falling 352 feet? So to answer this question, okay, we need to know after this object falling 352 feet, what is the time? Okay. So we can use the position function to help us to find that time, because after the object is falling 352 feet, so st, the position gonna be So right now the position above the ground level gonna be 455 minus 352. So that's 103. Okay. Because the position function tells us how far the object is away from the ground. Okay, so right now after it falls 352, the position is the difference of these two numbers. Okay, now s of t is 103. Now if we solve this equation for t, okay, so v0 is negative 24, and s of 0 is 455. So the equation has two solutions. One is a negative 5.5, one is positive 4. So we drop the negative answer. So t equals 4. So since t equals 4, the velocity gonna be negative 32 times 4 plus negative 24. So that's negative 128 minus 24. So it's negative 152 feet per second.